Harvard Cleveland published an article called Information as Resource in the Futures magazine in 1982. In this article, he tried to define information as a new kind of resource. It's different than the industrial age resources, which are tangible things such as raw material. And those tangible traditional resources are relatively easy for us to understand and to manage. However, in the post-industrial society, information becomes a very important resource. However, it is difficult for us to manage because information tends to be very abstract and intangible. However, both physical resources and information, when we treat it as a resource, can be mined, processed, bought, and sold, and certainly it needs to be managed. In this slide, let's first look at the circle around it, which I refer to as the information life cycle. You do need to understand and remember the sequence. We can start anywhere. We can start from data, which is the raw material that can be generated, and the data can be captured, organized, and stored, and eventually turn into information. And the value and the purpose of information is it can help us to make better decision, to reduce uncertainty in decision making. And decision, as Herb Simons usually argue, has 3 steps: intelligence, searching for understand the problem, and design, which is come up with some alternative, and eventually making a choice of what is considered a good solution. And decision certainly leads to action, and action would turn out to be some business event, and business event in return would generate some new data. So this complete the whole information life cycle. Now let's turn into the picture in the middle of this slide. Once again, this is still based on Harvard Cleveland's article. And in this picture, we try to describe some unique characteristic of information. For instance, the leaves of the tree, which is really an old punch card, 20-30 years ago, when we used to enter data into the mainframe computer. And it is used here to represent information. And information is expandable, which means information is almost like growing on tree and can be generated constantly. So we have something called information explosion. And so that's one of the unique characteristics. Comparing to the traditional physical resource, once you have mined the physical resource, like iron ore, there's less left. They're not going to be regenerated. And since there's an information explosion, and then we try to deal with the so-called information overloading problem, and information can be compressed, so information is compressible. To compress it, first we may need to organize it, and certainly it can be also filtered and condensed, like showing here. That's the second characteristic of information that's unique. Third is information can be transportable. Right now with computer and data network, it's much easier for us to send even a large data file across long distance, and fast and cheaply. And comparing to shipping physical resources, which can be expensive and much slower. I want to bring your attention to this part of the slide. Think about what it means. Okay. First, the building, kind of indicating it's a factory. And we have some people walking out of the factory holding something in their hand over here. And they are cursing, by the way. And the punch card flying in, which means information come to a factory. Most likely it's what we refer to as a factory automation, which means using information technology to improve the productivity in a factory. And because of that, maybe there's less factory worker we need to hire. Therefore, what they're holding on their hand could be a pink slip. And this is a characteristic of information. We call it substitutable. Information can be a substitute to other resources, can make us use other resources more efficiently or effectively. The fifth characteristic is of an information, it's diffusive. Information is diffusive. In this case, information tends to leak out to different places, and people are hungry for information, and they're seeking information, and so it can either formally be distributed or it can just leak out. Last, not the least, is this gentleman here handing out information to others. Information is shareable. However, it's different than traditional physical resource. A physical resource like a cake, when you share a piece of cake, you have one piece less. But when you share information, the information that you share with others, you still have it. So that's quite unique. So think about this. In this slide, I pretty much summarize those 6 characteristics of information. Expandable, compressible, substitutable, transportable, diffusive, and shareable. You should study Harvard Cleveland's article to try to understand this very important 6 unique characteristics of information, and particularly in the context comparing it with traditional physical resources. In terms of just a little bit, in terms of expandable, in one study on digital universe, it found that the world's information is doubling every 2 years. In 2011, the world will create a staggering 1.8 zettabyte. Okay, this is part of your homework. Find out how big is zettabytes. Just another news not too long ago, Sumlink, which is a news summarizing app, it was acquired by Yahoo for $30 million. It was an app developed by a young man in England who is probably around 20 years old now. He started a company at the age of 15. And that news summarizing app is basically dealing with this information explosion and then try to reduce the information overloading. Last, let me just make a comment on shareable features of information. Sharing information is considered a shared transaction instead of an exchange transaction. So when you share, you can share information with others, but unlike traditional resources, there is exchange happening. Sharing sometimes could be just for the good of the public and without anything in return. But certainly you can sell information to others and get paid in return. This is from the same article, another cartoon showing a very important concept. We usually call it information hierarchy. We're going to define the term information knowledge and wisdom very loosely, but in this case we're going to just look at the pictures. For instance, it's like an Asian caveman observing the nature. Find there's a rabbit, there's a cloud, there's sun shining, birds flying, and there's a tree, there's a string, there's grass. And so he's actually gathering a lot of data or information. Okay, here we would kind of talk about the difference between the two a little bit more. And then he later on find out those pieces of isolated information are related to each other. In this diagram, the author referred to this as knowledge. For instance, rabbit eat grass, and grass grows in soil, etc. So there's kind of a little bit more context and relationship among those pieces of information. And eventually he's making actually a much deeper realization and connections. His enlightenment is that he found out that if he kill off all the wolves, and the rabbit will grow rapidly, and as a result of that, the rabbit will eat up the grass, and the soil will all wash away. And considering this caveman is also a farmer, and when all the soil wash away, then it will be very difficult for him to plant crops and have a good harvesting. So although the caveman may not like the big bad wolves, however, he may want to keep a few of the wolves around to control the population of the rabbit. So that's what we call the wisdom. Okay, nobody have seen this bigger picture, this kind of cycle of the food chain and its impact to the environment. But if you can see that, and that actually is something we may refer to as wisdom. Let's use so this information, knowledge, and wisdom is a hierarchy, and some people only use data, information, and knowledge to describe this hierarchy. Earlier, sometimes the difference between data and information, it's really a relative term. So a lot of time you don't really want to get into a debate with someone in terms of what is considered data, what is considered information. It's all relative to who you talk to and what's the purpose of that piece of information or data. So study this slide, and for instance here we find out that data can be easily transferred. They are very structured and can be captured easily. They are basically objective facts about the world. At the lowest level, it's just bits and bytes, number, text. And information basically has a little bit more meaning, and we need to provide relevancy and purpose and what we want this for. If I tell you the temperature in Camarillo, California is highest temperature today is 80 degrees Fahrenheit. It may not have any purpose to you, but if you travel from out of state and coming here, and that's a very important piece of information. Knowledge in this case are insight and the contextual information which help us to use the information properly. However, knowledge can be very difficult for us to capture and to codify and store in the computer system to help us to use information or data more effectively. And because most of the knowledge we are considered so-called tacit knowledge, which is very hard for the expert who has the knowledge to describe clearly what knowledge the expert may be using in making a judgment. This is a simple example. If I just tell you the price is 5,000, it doesn't mean much. That's a piece of data. However, if we present the data as part of the structure, which is basically we provide the context, and then we can turn this data into a more meaningful, useful information which can help us to make some decision. In this case, we realize that 5,000 price is actually a used car. It's a Ford wagon and a 94 model. So this, if you're thinking about a used car, certainly this is a useful information. So information is relevant if it can make a difference in terms of help you to decide whether you want to buy this used car or not. Comparing to that Ford wagon, if you see, hey, there's another BMW, actually a newer model, 1997 model, costs the same price, $5,000. Okay. Then it sounds like this is a better deal. Okay. There are additional information from Consumer Report. It will tell you that different years of used car models average selling price, and you may realize that the average selling price is 19,000 and this used car is only 5,000. So that's really a good deal, and you may rush to purchase this one. However, with such a difference, it just sounds too good to be true, and you may want to actually check out this particular used car and make sure there's nothing wrong with it. Okay, and that's kind of your tacit knowledge is telling you to some extent that when you use this information, you need to be very careful. You need to look at a lot of factors. The highest in this so-called knowledge value chain model is the so-called knowledge. We're using now a different scenario to describe it for you. For instance, this is a loan application program. A loan officer actually have to decide whether a loan should be approved or not, or how risky it is. He or she has to look at the credit score of the applicant and the current asset they own, and also the loan amount in order to determine the risk level. Okay. And a piece of knowledge in this case represented as a business rule can be stated as the following here. Like, if we know the applicant is our old customer and his or her credit is considered good, and the applicant also has asset twice the amount of loan, and then the risk is considered low. In this case, we probably the loan should be granted. So this business rule is often referred to as knowledge. So knowledge in this case, when we use that loan application example, when you want to apply that decision rule, production rule, in making a loan decision, you still need to have additional information like basic customers data and some of the additional information about your customer, their past history, their credit information, etc. in order to make a decision, and eventually you take some actions such as approving the loan or explain to the customer why the loan application has been denied. So knowledge by itself is not enough. You still need input, information input or data input in order to apply the production rule, the knowledge. So put it together, if we kind of combine the two models, this is what we call, sometimes referred to as information hierarchy or DIKW hierarchy, means data, information, knowledge, and wisdom hierarchy. And data usually are generated by event, so we actually need to observing the event in order to capture the raw data. And once the raw data has been captured, then we need to analyze it in order to provide the context and transform the data into information to help us to make better decision. And once we have collect a lot of information, then through a learning process, we can derive production rule, business rule, policies through those experience and by observing certain general pattern. And last, the most difficult part is once we have those knowledge, those causal relationship, those production rule, if we can integrate them and particularly connecting the dots, have a more holistic view, then wisdom can be generated. And this is certainly the toughest part. We haven't been able to use computer, I guess, to achieve great success in generating wisdom. One scholar actually described this like event is happening and doing. Data without context is really nothing. Information provides you with some context so we know what it is. And knowledge tells you how to do things, how to actually apply the information to make decisions. So that's kind of know-how. And wisdom is know why, which means bigger pictures, the purpose of things. This is another way to describe the same pyramid, and slightly different. Here the T and C and E represent tacit knowledge and explicit knowledge. Tacit knowledge is more experience-based. It's very hard to codify. Explicit knowledge can be easily codified and enter into computer system and to apply it. In this picture, we're referring to the data, information, knowledge, and add actually another layer is understanding, explanation, and that's why. Refer that to the historical data information about the past. Wisdom is help us look at the futures, and it's a kind of value judgment. Consider what is the best. Okay. Data, information, knowledge tell us doing the right things, doing things right, which is more on efficiency. And wisdom is about doing the right thing. Last, I want to leave you with T.S. Eliot's poem called Chorus from the Rock in 1934. Where is the life we have lost in living? Where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information? So in this case, we're working our way up from information to knowledge, from knowledge to wisdom, and from wisdom to the meaning of life. Thank you.